You're looking at pictures taken by Professor Terry Hughes during his recent study trip to the northern parts of Queensland's Great Barrier Reef. It's an area he knows well.
I first visited there in 1990, so I revisited earlier study sites, and the changes there are quite dramatic. There's a lot less coral now than there used to be.
The reef has had to deal with cyclones, an invasion of the coral-eating crown-of-thorns starfish, and most damagingly, the impacts of climate change. Professor Hughes has spent the past 3 decades documenting those impacts.
We saw the first mass coral bleaching event on the Great Barrier Reef in 1998, and that was really the first wake-up call we had here in Australia about the threat from global warming.
But that wake-up call did little to stem global emissions of greenhouse gases. Since 1998, the reef has endured multiple bleaching events.
Bleaching is a stress response by corals. If you take a coral into the laboratory and torture it by changing the salinity or the temperature or adding sediment or testing toxic chemicals, it will bleach. The whiteness is actually its skeleton, showing through the translucent tissue like an upside-down jellyfish.
Bleached coral is sick coral, and back-to-back bleaching events in 2016 and 2017 meant many couldn't survive.
In 2016, we lost about a third of the corals on the entire Great Barrier Reef. Most of that loss was in the northern third of the Great Barrier Reef, where more than half of the corals died over a period of just a few months following record-breaking high temperatures.
Professor Hughes and his team saw it happen.
And the best way to do that at the scale of the Great Barrier Reef, which is 2,300 kilometres long, is to get in a small airplane and crisscross the length and breadth of the reef. It takes about 8 days to do that. We also have to ground truth that data underwater. So in 2016, I led a team of about 100 people who spent about a month underwater measuring in situ on the reef the amount of bleaching and the amount of mortality subsequently.
He also told the world what he saw. One of his social media posts was retweeted by actor and environmentalist Leonardo DiCaprio, reaching an audience of millions.
We no longer have the luxury of waiting a year or two from collecting data, analysing it, publishing it after peer review in a journal. The timeline for that might surprise people. A year's really fast. It's more typically about 2 years. And that's a big gap if you're trying to communicate important information to a general audience.
Professor Hughes says reaching a mainstream audience is critical in securing the political will needed to enact the kind of changes that could save coral reefs around the world.
I think it will probably get worse before it gets better. We often use the term running the climate gauntlet for coral reefs. What we really need to see is global temperatures stabilize, hopefully at somewhere close to 1.5 or 2 degrees. If we can do that, then we will still have coral reefs in the future. They'll be quite different from the coral reefs of today and certainly the coral reefs of 30 years ago. But I think if we can curb global warming at a reasonable level and give the corals time to respond evolutionarily, which will take a couple of decades, then we will see a rebuilding of coral reefs if we can stabilize temperatures at a sufficiently reasonable level.
His career studying, understanding and advocating for coral reef systems has now seen Professor Hughes awarded the prestigious Suzanne Cory Medal from the Australian Academy of Science.